All right, it's being recorded. So let me give a introduction to the course here, class. Welcome everyone. This is the Computer Science 350, Section 6, Operating System, week number 13. And today is Wednesday, April 10th. And this is the recording. As usual, if you can, some of you already did it, private chat with your name and ID that we counted as an attendance. A couple of announcements. Feel free to let me know if there's anything that you want to say. But I just want to make sure that everybody is either registered or registering, but without any issues. Make sure you reach out to your advisor and get your PIN and work out your courses for the fall. Schools can offer summer schools, including Lewis. So if you have any plans to take any classes either at Lewis or any other schools, make sure you get that approved and all planned out beforehand so that it doesn't become a surprise for you. Let's see if anybody is. Give me 1 second. If anybody's working on a OS project, let me know. And by email me with an update, because the end of the term is coming up soon, and I like to keep track of who is working on the project as an option. This is a totally optional and only as for extra credit. So if you're not working on it, you have nothing to worry about. But if you are, just keep me posted on how you're progressing. I also want to say, if you look on the week number 15, it should tell you that things are due on May 5th. So all assignments are due on Friday, May 3rd, midnight, Central Standard Time. Okay, so that is a hard due date. So this is a hard due date. And the reason for that is because I need to process the grades and submit them and stuff like that. So this is not the last day of the semester. You can see that from here. We look at the academic calendars. Here's the spring term. So there is the final day and all the commencement stuff like that is happening on the starting May 3rd or 4th. So make sure that you pay attention to those dates. Okay. All right. So is there any questions or comments anybody want to make or ask before I get to today's material? If not, then I'll just move forward. And if you think of anything, just let me know. Okay. So today, week number 12 and 13, but today's the 13th week. Well, I'm going to finish the file worksheet, and then I'll do the lab portion. Okay, so if you look on, let me move this out of the way and make this a bit bigger. So here is the worksheet. So if you click on that, okay, there's a question here. Okay, so there was a question about the OS project. So let me just make a brief comment about this. I think there was a, so maybe, not sure why it wasn't posted here, but what I'll do is I will post OS project after class tonight. But basically, what it is if you look on week number 14 next week, I'm giving you part one of the two-part operating system installation and setup. And basically, as I may have told you already, that this and week number 15, the part two, basically just starts up and then says hello or something like that. So you can, it may be, a little bit late now, but if you want to, then you can add any other function to that operating system that I gave you, or you can start from scratch, not only to boot. So here, basically, to boot and one functional feature, like a let's see, file system, or how to get the browser going, or anything like that. So any other function that you can think of would be. And there are some websites out there already, both free and paid versions of it, that you can look and basically follow. So you are allowed to do that, and you're certainly allowed to leverage ChatGPT. But I'll post something like this after tonight. Okay? All right, so because I kind of want you to, especially if you're pretty okay with programming, then be able to spend some time developing your own operating system. Okay, I think I posted on other sections. I'm not sure why it's not here, so it should be shortly after the class is over tonight. But yeah, you can research and stuff like that. Anyway, so today, 13, let's see here. Let's see. There's the download. So this is the the worksheet that we were working on, and so I'll pick it up from. I think we did only up to 4 or 5, so maybe I'll do 6, but I may look at 5. Let's see if I can bring up. Side. Oh, very good. I'm gonna make it a little bigger. I think we were at number. Here we go. I start from number 5, just in case that I didn't cover it, unless somebody remember whether I did or not. If you let me know, then I can skip it. But either way, maybe okay to start from number 5. So here, we're talking about the file system, and we are using a Linux inode file system here. And then this, the question is telling you that it is a one-level file directory. In other words, rather than here a single directory or any other directory, you only have this block is what they're saying. Okay, so which is kind of drawn out this way. And the block size is 4K, which is a decent size, better than 1K. And the question here is, what is the maximum possible number of files? So I'll be asking two questions. The first question is, how many files can you have? Okay, so that's the first question. And the second question is, what's the largest file size you can have? If you were to have only one file, how big can it be, right? And and so these are the kind of questions that the file system needs to know, partly because of an individual users, but as a system administrator, you want to know the maximum number of files that your server or storage device can have based on your file structures. Okay, because if you have clients that is growing, the number of people who will have files on your server cannot be infinite. There will be a upper limit, and also there is a file size limitations that it'll run into. So you need to kind of know that, and you can't just guess what they are, because you have to, all these things translate into money. Okay? So anyway, the number of files you can have in this particular setup is, I think they told you, let's see here. From this drawing that they give you, it is a 8-bit entry per data block, and the disk block is using a 32-bit entry per file. So if the size of each block is 4K, meaning that this is the one basic unit block for your data. But if each of the file entry has to be used by 32 bits, then how many of them can you have? You simply just divide them divide them each other, right? So if it's a 4K 4096, 4 times 1024 will give you 4096, and this is in bytes. And so if you got 32 bits addressing going on, and then divide that by 8 to get 4 bytes. We will assume that 8 bits to a byte, which is a fairly standard. So we'll assume that, and if you can cancel out the bytes, you just get 1024 blocks. Okay, so that's the number of files that you could have for your system, which is not a lot. So I don't want you to be surprised by file system that not too many people can actually save their files on yours. So if you look at Google Drive or any other online storage, that is huge. Okay, so it actually does cost a lot of money. But if they were, this is individual blocks or individual files, then how many? What's the biggest file you can have if you had only one? Well, then if you had a if you had a 8 bits are used to represent address or total number of block detail that can be accessed to the date, or 256. This is the maximum number of block size, file size in blocks. So just basically apply to that 4K block size, and you're going to get 1 gigabytes, right? So while that your number of files is kind of small, the actual size of a file that you can store is huge. Of course, if you have this file, then you cannot have any other file because this took up the whole thing. Okay, so you don't want to allow user to submit large files. The users want to upload large files, but from the provider, you probably don't want to do that, right? So for Gmail, I think you have to. I think you can only submit or attach a file that is only 25 meg, right? 25 megabytes. So that's kind of small, and so typically without paying anything, right? So there's a reason for that because it costs money. Number 6, I feel like I should have asked this question sooner, but I kind of forgot about it, and so or maybe maybe just I forgot to reshuffle it in order. But basically, what it's asking is asking about the inode file structure, which we already talked about. And so this is the inode file structure, and used by Unix file scheme. And it's pretty much the same as any other file system. It'll have all of the basic information about the file, when it was created and stuff like that. What is unique about this inode Unix is that it is using a pointers to get to a data, but also it'll use a layers to get to the rest of the data. If you had a only limited number of pointers for this block, then let's say you had only 10 pointers here, and if the data block is only 1K, which is may not be the case, but anyway, then you can only have 10K files, right? So which is not a lot. So if you wanted to have more files than 10 file data blocks, then you can use single direct or double direct or triple direct to get to more of them, right? More of these data blocks, if they're available anyway, right? Single indirect just means that you'll create a data block here that gives you a pointer to the actual data, just like here, right? And then some of them could, or in this case, all of them should be pointing to the data if there is a data that is just, stored in your file structure. You could also, if you run out of these, then you can have what's called a double indirect, where you'll get a block of address where it points to not just the data, but another block that you can point to the data. So you can kind of exponentially expand how many data blocks you can have. Of course, you can have a triple here, like 1, 2, and 3, like that. And also, you can have this data coming out of the first data block. They don't all have to go to the second layer, because if you only have 2, the pointers in the middle is sort of wasted, right? So you could have some of these point to the actual data, but we don't use this much in personal computers because we have a huge size of the memory and storage, so this kind of scheme is unnecessary. But for mainframes, and especially the government and really large companies that does a lot of storage, they still keep around Unix derivatives and use inode structure. So it's kind of helpful to kind of know about it. So let's do the one more example, and then this will be the end of worksheet. So here, we're still a Unix style inode. Is telling you that there is a 10 direct pointers, right? And then 1 single, double, triple each. And then it's telling you that the data block size is 1K, which is kind of small, but still telling you what it is. And the initial configuration of the operating system will decide this, or which includes the file structure. But it is also letting you know that this block address, these guys here, is you have an option of either 32 bits or 48-bit, right? And so but you have to decide which one you're going to use. So we'll answer that question also. But basically the question is, what is the maximum possible file size? And what's the largest file size you can have, right? If it was only one. In other words, if all these data blocks are, or they all belong to one file, right, term paper or whatever, right? Then how big could it be is what they're asking. Okay? So before we answer the question about 32 or 48, what do you guys think? Should we use a 32 or a 48? Let's see. There it is. 32 would preferably come out with a clean number. Okay. So that's a good point. Let me see if I can draw this here. So if we have 32, right? So basically all what we're asking is, if we have a data block here, 32 and 48, and so if we had a little bit bigger like that, 32 is a clean number, as somebody said. 32 is equal to 2 to the, I think it's a 2 to the 5, right? Is that what it is? Let me just double check. 2 to the power of 5 is, yeah, 32. So, since we deal with a binary and all that stuff, so this is a much easier to manipulate, and it's a clean number. But if we use a 48, then we don't really have 48 as it is, so we'll have to do either probably like 64, which is a 2 to the 6, right? Which is one more there. So we're increasing the bit by 1, which is not a terrible investment. But if you have 64, then you cannot, you're using only 48 here. So the rest of it here is not used, and which is okay. Maybe this is useful for if you expand it later, but which is unlikely. And so 48 will still give you a lot more, data blocks here than 32. So if you really need, if you're looking to, if you say I have lots of small files, and I'm worried that if I have only 32, I'm not going to have enough, then 48 would be better. But so that's a toss-up. It's not really trying to say one is better than the other one, but the question is a little tricky to see why you choose one over the other one, right? And if the files are sort of a mix, there's a small ones, there's a little bit larger ones, then this is probably okay, and obviously has the advantage of not wasting anything. So either one's okay, but you kind of need to explain, okay? Which is not the main point of this, but it kind of is through in there in this a certification question. So anyway, so let's go with 32. And so this is what we're hearing from the problem. We're told that there are 10 direct blocks, and there is one of these guys each, one single, one double, and one triple. Okay. But we're also told that the data block, each of these is a 1 kilobyte. Okay. And each of these blocks here is 32 bits. Okay. And we wanted to know what's the maximum possible file size if all these blocks are they belong to one file. Okay. So if we write that again, highlighting some of these, and so the number of addresses per block, okay, since it is a 1 kilobyte and 32 bits, we're going to go with 32 bits, and 32 bits is a 4 bytes because we are assuming that 8 bits to a byte. So to keep the units the same, make it a 4 bytes, then you'll have a 256 of them. Okay, so once you know, then all you have to do is just add up all the data blocks for each one of those layers, the direct pointer, single, double, and triple. Okay, so 10 direct pointers, so you got 10, and 2 to the 10th power is a uh, 10 1K or 1024. So this is how many bytes you got using from the 10 direct pointers, which is right here. Okay, but you also need to add the data blocks that are available from the single pointer, right? So since we decided that number of addresses per data block was 256 or 2 to the 8th power, this is what you got. So this is the size of these guys here. Okay, so that's how many data blocks it's going to have. And each data block is going to be 2 to the 10th or 1K, right? So since it is a single pointer, you multiply just one of that and then 1024. For the double pointer, you use 2 of them. And you multiply them because they're multiplication of each other, right? So, and then if it's a triple, then you multiply 3 of them, and then the size of a block, which is 1024. So like here, you got these, there's layer 1, layer 2, layer 3. So the total of these is a multiplication of these. Okay, so I hope you're not confused about that. And basically all you have to do is just add them all up. Okay, and then as we saw this number before, it's a 1.7 gigabytes. And so that's how you do the calculations. Now, if you ever work in an enterprise systems, after you graduate or even now, and they're designing a server using Unix data structure, they're going to ask you these kind of questions. But this kind of calculation is not too bad. But the real reason why they would pay you money is because they want to know, is this good enough for the organization? So, not you, but you as in the company, right? Are we going to make money on this? Should we allow the largest file for user to upload is this? You don't want to do that because if one guy uploads the file this, then no one else can do it, right? So you want to be able to at least find out the maximum. But you also want to go back and revisit these pointers so that you could have maybe better a maximum number of data blocks, and then limit the largest file that you want to have, and find a profit margin that is reasonable for the users. So there are some direct money involved in this kind of calculations. Is there any question from the worksheet? Okay, then I'll take that as everything's okay. So let me close that out. Let me take you back to the here. And so now what I want to do, can you go back to number 6? Yeah, sure, I can do that. Number 6 was a simple a definition question. So like here's a number 6. What is an inode and what information does it contain? So, this is what's on here, right? Does it sound okay? Great. All right. Yeah. All right. So there's a lab portion here that I want to do. And so if you want to just click on this. Before I start anything, notice how I rearranged the lab here under 2 different headings, where here's one for the Windows and here's one for the Mac OS instruction. But I don't know if I really need to post it for you because all you have to do is make a small change. So if I do have time, I'll post this up, but I don't know if I'm going to have a good access to the Mac for me to test out. And but I'll point that out for you as I use this. But anyway, just click on this file system instruction. So the purpose of this lab is for you to get some detailed information about a file using a program. We all know how to do that. Like, for example, if I have a, let's say I just bring up my here, and if I go to, let's say, C drive, and then I go to maybe a temp or something, and if I want to get a file information about this file called A, text file, all I have to do, at least on a Windows system, right click on it, and then just click on the properties. It'll tell me it's on the other screen. So let me bring this guy over here. It tells me that it is on C drive, the name of the file. No, that's not what it is. So let me get this guy here, properties. Where did it go? Let me try this guy. Interesting. Oh, but anyway, so you can, get the information from here. Just click on the properties, and it'll tell you what it is, right? It tells you here it is. It's a file 2. It's a text file. You can open it with whatever, and then it tells you how many bytes it is. But notice here carefully. I don't know if you can see. So I'm gonna just take a screenshot of this and then expand it out. Okay. So I'm going to minimize this here as a way of explaining this out. Can you guys all see this okay? Notice here, the file size, so this is the name of the file that I looked at. This is the file size here, 25 bytes, file number 2, okay? So if I open that file, this is file 2. If I open it up, this is what I have. There's actually stuff in here, right? So it's not a fictitious, but what it's saying here is this size on disk is 0. What's going on? How could a file that has data take up no space on the disk? And this is really contrary to what I see right here. So let me move this guy a little bit here and then make it like that. When I look on my folder information, it says the name, date, type. What did you say? It's 1 kilobyte. There seems to be a inconsistent information about the file size. This one says 25, but the size it says is 1K, and the size and stuff is on the disk is 0. What do you guys think? Which one is right? Anybody? Somebody? Well, 25 bytes. So 25 bytes is, I think they're all accurate. But let's see here. So if I open it, okay, if I open this up, okay, file 2, this is the last location. There is no, invisible lines or anything like that. So I'm going to count how many characters there are, okay? It tells me there are 23 characters on the bottom here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. So this is correct. There are 23 characters, but there is a end of a file character, right? And there is the beginning header of this file. So that's why there's 25. But whatever, there was the one question coming about in the RAM. No, files are not in the RAM. When you open it, it goes into the RAM. But when if I close it, it's got to be in the disk because whatever is in the RAM goes away, right? So all my files are on my storage device or hard drive. So, but the Windows has a scheme where if it is really small, and really small meaning like less than 100 bytes or something, are stored in particular location of your hard drive together, right? So they are not located in the same areas as other files are. So this refers to the conventional size if it is on the regular storing place. That's why it's a 0, because it is not a 0, but that's what this is saying. But also here you can see that the smallest file, even 25 bytes, is taking up a 1 kilobyte. And what that should tell you is that my file system, my data block is 1 kilobytes. Okay, so if you have just one a character or 1 byte, it's going to take up a 1 kilobyte of whatever it says on the file information. Okay, although this doesn't take up a whole lot, exactly 1K, because they're stored in some other place. But anyway, let that be a prelude to for you to think that when you get the file information, manually or otherwise, personally or from somebody, you need to verify that. And it's hard to, and if they send you all these things, 25 bytes, 0 bytes, 1 kilobytes, you got to figure out which one it is. And it's not as easy as, we usually think. And, for personal use, it doesn't really matter if it takes the 1 kilobytes, who cares, right? I have a gigabytes and stuff. So I got, and if it runs out of space, I'll get a new one. But from the system administrator side, you want to be able to get it exactly right. Okay. So, we're not going to be able to do some fancy ones, but that's what's in the backdrop of this file lab. Okay. So let me get back to the file lab here. Let me close this guy out and get back to this one. So basically all you need to do is to get the file that's posted on the Blackboard. Okay, well, where's it at? Let me show you. So here is the lab. Okay, here. So I gave it to you, and you can just click on this add one zip. And if you go to the the download, and if you got the zip file stuff going, then it should just open up to a regular folder. Taking a little time. Here it is. And if you open that one more time, you should see the supporting the Python and the text document that it is using. So you can use this, but when you're doing this, I'd like you to use, preferably something like PyCharm. You don't have to use a PyCharm, but use something like Spider or whatever. But don't use like a Thorny that I sometimes use, because Thorny is nice and easy, lightweight. It's kind of convenient, but it is just you don't have multiple file structure like they give you on PyCharm. Also, try not to use one of them online compilers. I think, for example, if you got the program is or tutorial whatever online, because you only have one page. I mean, I think there's a way to figure out you could have multiple pages, but that's not really not. So just use the something like a PyCharm. But in my demo is going to be in PyCharm. So Make sure, so let me start the PyCharm. Oh, here it is. So it's starting up. And basically, what I wanted to say in this Word doc is make sure that you set up your Python or PyCharm under the project with two tabs, one for the main, one for the sample. Okay, and so that's what I got right here. Here's the main. Here's the Python program, and then here's a sample text that I'm going to use to play with. Right. So I think this is basically what I had right here. And then I'm going to just say, so if you look at the program, a little carefully, there's supposed to be a whole bunch of screenshots that you have to submit. So like, for example, here's a screenshot 1, here's a screenshot 2 after you run this portion. And I think there are 5, right? So, but you don't have to do that. You can just run the whole thing and then take a big screenshot and say, this is a big screenshot for all of them. But if you really wanted to run them individually, then you can just select that, right click on it, and then click on the execute selection in Python console, and it'll just run that for you. Yeah, so you can do that either way. I'm just going to run the whole thing, but yeah, let me just run that, and then I'll talk about it. So I just ran it, and so here is some basic information about the environment. So here is the pathway where my Python executable program is located. But here's where my project is located, right? So I'm going to just copy this and then get over to that location on my folder here, okay? So I'm going to, that's probably the same one, but whatever. Okay. So here it is. So here is the sample file that I should see right here. This is line 1, 2, 3, 4 with the last line, but the first word, this is spelled with TIX. And then if I open this guy up, yeah, that's on my folder, then I should see the same thing, right? It is the same thing, so that's good. Okay. So what this is doing is it's giving me the date that it was created, some information about them. Here's a file size of 74, right? So if I open this up, it still says 1K because that's the data block. If you look at the notepad here, it just says 71 because there are 71 characters that I could see, but there is a end of a file flag, and which is a byte and stuff like that. So it includes all the characters, all the symbols that go with that. But anyway, so this is basically what you're doing, and I just want you to see how it is. And also, if you look at the main program, I think one of the times it asks you if you want to ask you to put a so here you can see that is April 10, 6:44, which is like 2 minutes ago. I'm going to put a line here, and remember that this was a 74. Okay, so I'm going to remember. I'm going to put it right here, not on that one. 74. And then I'm going to put a capital A, right? And I'm going to run it. Okay, so then what's gonna happen is, the timestamp should change. And when I open it up, the number of characters should also change, right? So let's do that. I'm gonna click run. Does the same thing. Now, if I refresh this guy here, or actually it's real time, it's 6:47. When I check here, it says 6:47, so that's good, right? So, but remember it was 74, but now it jumped to 77. What's going on? I added only one letter, capital A, but it jumped by 3. So, maybe, that could be a food for thought. But anyway, I just want you to know that, let's open this up and see actually how many there are. Okay? It says 73. Okay. It was 72, I think, right? Whatever it was, I'm not sure. But anyway, at least you should notice that I not only added one character, but I added a carriage return. Okay, so that's at least 2, right? So anyway, there's some, little more stuff that we need to talk about. But anyway, so basically that's all I want you to do, and run that program. If you want to just take a one big screenshot and submit, that's okay too. All right. Any question about the lab I just demoed? All right, I take that as everything's okay. So we are able to take one. Yeah, of course, we can do that. Oh, with the output, yes. And when you take a screenshot, try to maybe, I don't know if you can take one big one that captures everything. But let me see if I can get rid of this. Let me see if I can just run it again, and then see if everything is in one screen. Yeah, pretty much, right? So you can kind of go up there like that. That should be okay. Yeah. So this should be okay. If you're a little worried about it, then take 2 screenshots, right, and showing whatever. But this is what I would do. I would when I take a screenshot, I would take it like this. Like this. So that it shows the program and the output, right? I think there's a way to see if we can print this. I wish there was a way to print this in as a PDF, but maybe you can figure it out. But either way, yeah. So I think that's okay. All right. Any other questions? All right. So that's all good. Let's go back to the Blackboard. So that's pretty much all you have to do for this week, that lab. Looking at the next week here, so we're kind of winding down. So next week you have just one, you have the Zybook, but you have only one lab, which is building the OS part 1. So if you put off your virtual machine creation before, make sure you get that working before doing this, because you're going to need it. But here's a detailed instruction on how to do that and all that stuff. So, take a look at them. That's the part 1. And then week 15, it's the part 2. Okay. So, and we're pretty much done. So my action item for today is to post up some project information if you want to do that. And so, this could be just extra credit if you want to, and you can use whatever resource you want. You can copy from the internet, you can copy from, paid whatever, use a ChatGPT to write it for you. I don't care how you do it, okay? So that's an option. And, it's not easy, but I think it kind of makes you think about putting all the stuff that we talked about, together. All right, and then, next 2 weeks is gonna be really easy, just because, that's pretty much done, and so it should be pretty straightforward. And so you do have, until, May. Everything's due, oh, yeah. So I don't think, yeah, so May 3rd, so you have exactly, 1, 2, maybe 3 weeks to go, and voila. All right, guys, any last minute questions? All right, I'm going to, well, then have a good, evening. If you have any questions, feel free to email me, and look forward to getting your, assignments. See you next week.